we can square a difference, meaning we can take a minus b and take square. Then we can use the following formula: a squared minus 2ab plus b squared. In this formula we can motivate using this figure here. So if you start with the first row of this figure, then we say that we have the same number of balls on both sides. We have the square of 5 on both sides and the square of 3 on both sides. Okay, so if we have this, then we can move all the yellow and green balls to the other side. Then we will get this equality instead. And the equality sign must still hold, since we have taken this number of balls, removed them from this side, and also removed them from this side. So the equality sign must still hold. Okay, so what do we have then? On the left hand side we have this little square. We had 5, a square of 5. So this side was length of 5, but then we removed 3. So we can write it as we had 5 this length, but then removed 3. And 5 minus 3 is 2. So that's the side of that little square. So the number of balls here is 2 squared, or 5 minus 3 squared. What do we have on the other side? We have 5 squared. And then we take away these 2. But these 2 contain the same number of balls. We have 2 of those rectangles of balls. And we have 3 times 5, or 5 times 3 if you like. And then finally we have 3 squared. If we now look at this equality here, this is just a special example of this, where a is 5 and b is 3. So this figure here motivates this, a special case of this formula. But we could have chosen other numbers than 5 and 3. We could have chosen other numbers, at least that this is bigger than this one. And then we would have motivated also this for all types of numbers, where at least this difference is not negative. So that motivates this formula.